Okay, so on this last one, we're going to look at last couple of pages for this chapter. We're going to continue looking at quantitative data, mainly histograms, only histograms really, and what we can tell from looking at them. So the first thing we're going to talk about is the mode, and the mode is just going to be a high frequency bin. And typically, probably if you heard this in high school, you would say that the mode was the most frequently occurring data point. Typically, though, especially in this class, we're just going to, when we have a histogram, it's going to be the one that is the tallest. So we have a unimodal where you just have one, we have bimodal where we have two, and then multimodal more than two. The thing to point out here is with the bimodal and the multimodal, they don't have to be the same height. So we don't have two that are equal as far as most frequently occurring, but they are tallest in the area around them in their little neighborhood. So that's really all we're looking for with the mode. So then we have uniform distribution. If I get it to sit on there. And a uniform distribution, all the bins are approximately the same height. And kind of like the mode, they don't have to be the same height, but if you look at this one, there's none that stands out much higher than the rest. So obviously there's a little bit of differential. You're never going to have a perfectly uniform distribution in real life anyway. But if they're all kind of the same height, there's no one that you could call a mode, then you would say it's more uniform. Symmetry, I think we all, intuitively know what symmetry means. We'll just draw a picture. So whenever we draw histograms, I'm not going to draw individual bins like this. We'll just kind of draw like what line would kind of go over, just kind of outline the histogram. So symmetric histogram would look like that, or it could, if it was bimodal, it could look something like that. So that would also be symmetric. Although the unimodal is most common, and especially with what we're going to be doing in this class, we're going to mostly be working with the unimodal symmetric histogram. And then we have skewed. So we have skewed left and skewed right. And I'll draw these up and usually have people guess in a live class which is which. So if you had to guess, which would you guess? Maybe think to yourself, which one would you say is skewed left? So this one is actually skewed left, and this one is skewed right. And at least for me, it's always been the opposite of the way that I would have named them. But we talk about the skew. These are the tails here, and these are the longer tail is on the side that it's skewed. So in that case, it's skewed right. In this case, the longer tail is on the left, so it's skewed left. So it's one of those things. To this day, I still just kind of think it's the opposite of the way I expect it to be. It still does not seem natural to name it the way it's named, but that's the way it's named. So that's the way we'll learn it. Then we have outlier. So outlier, and you can tell from this picture here, outlier is just a data point that is far from the rest of the data or data points. So outlier is a data point far from the rest of the data. So how far is far? Well, I guess unless we quantify it in some way, which you could, we may not get there, we may. But if there's a gap in the histogram and you have one bin that's kind of by itself, you could probably call those outliers. So it'd probably be good enough. All right, so let's look at this example. So we have the histogram shows the amount of money spent by a credit card company's customers. Describe and interpret the distribution. So what can we say based on these things that we've kind of talked about? It is unimodal, so we definitely have one that is much higher than the rest. So unimodal. Then we could say it is skewed. Which way would that be? Skewed to the right. because we do have a longer tail going to the right. And then you can see we have one point out here that would be an outlier. So that one is much higher than the rest. And it looks like it's around 7,000. Outlier around $7,000. So that's the kind of thing that you look for in these. We'll talk about a couple of other things. But just generally speaking, those are some characteristics that you can pretty easily notice when you look at these histograms. All right, so next we have several terms, and a lot of these, at least some of these you probably have heard of. First one is the median. So the median is the center of the data. So with quantitative data, you can, they're all numerical, so you can line them up numerically, and then the center, whatever the middle data point is, that's the median. So half the data are below the median, and I won't write it down, but we could also say that half the data are above the median. And then for symmetric data, the median is right in the middle. It's in the center of the histogram. And with skewed, it's going to be to one side or the other. We'll talk about that too. Then we have the range. So the range, we'll just write a formula here. So the range equals the maximum data point minus the minimum data point. That just tells how spread out are you. So that's a measure of the spread. Percentiles, I'm sure you've heard this if you took, say, your SAT or your ACT or some other standardized test. And you got your scores back and it said you're in the 80th percentile or the 70th percentile or the 95th percentile. What does that mean? So if you're in the 80th percentile, that is the data point that is above 80% of the data, or the rest of the, in the test score case, the rest of the scores, the rest of the students who took the test. So higher percentile is the higher on the scale of data that you would be. First quartile, that would be the 25th percentile. We could also call this the median of the lower half. And then the third quartile would be the 75th percentile. And then IQR, we're going, so that's interquartile range. We'll just write a formula for this. That is Q3 minus Q1. And so what does the IQR tell us? The IQR, so this is the 75th percentile. That is the 25th percentile. Between these two, that would leave 50%. So the IQR measures the range of the middle half. So some of the benefits to the IQR is it is not sensitive to outliers. So outliers are on the outer edges. If we're only looking at the middle half, then that's not going to be sensitive to the outliers. And we'll see some things that we'll learn later, how outliers can be a little bit troublesome, and usually we need to pay attention to what the outliers are. But if we're looking at the IQR, the outliers don't really matter. The IQR provides a reasonable summary of the spread. And it also shows where typical values are. Okay, so some benefits to the IQR. And so probably I mean, that one may be fairly intuitive formula to memorize, but you certainly need to know IQR, have that formula in your brain. Um, so a lot of these things we'll learn how to do on the calculator, but the IQR is not explicitly given. You can get the calculator or whatever statistical software to give you Q3 and Q1, but you got to know what to do with those. So if we're talking about the mean, obviously we're just talking about the average. And we're not going to manually be calculating average. We can get software to do that or a calculator to do that for us. So the mean is just the average, and mean versus median. So I think we'll do something different here. Let's draw skewed histogram. We'll draw a symmetric histogram, and we'll draw the other skewed. So skewed left over here, symmetric, skewed right. Now we have the mean, the median, and the mode. The mode, as you know, is always right under whatever the tallest bin is. So that would be the mode. And then now where would the mean and the median be in relation to the mode? Well, as you can imagine, I'm sure you know how to calculate an average. You add up all the data points, you divide by how many you have. So if you have any outliers, those are going to be in the calculation for that. And the outliers, and you probably have experience with this. You may have been taking a class and you're doing pretty good. You get some good grades, have an A or a B, and all of a sudden you get a 0 or you fail a test, make a 10 or a 20 or a 30, do really bad. So that score would be the outlier. And then what does it do? It pulls your average way down. So the mean is going to be pulled out by the outliers. And I'm exaggerating a little bit, mostly for space. But so it may not be way down here, but it's definitely going to be lower in this case than the mode. It's definitely going to be higher than the mode in this case. And now where would the median be? So the median is not affected by outliers because whatever that center data point is, that's the median. It's not the outliers, if they have them, are not involved in that calculation. So the outliers are not affecting the median. So the median, it will be pulled a little bit this way. Again, this is a little bit of an exaggeration. It's probably going to be closer to the mode over here, but just so that we can see where it is. Because the order is more important than where it is on the histogram, because that will, of course, depend on the data set. But the median will be somewhere between these two. And that it's also easy to remember that because the median is a center data point, and between these three, it's always going to be in the center. So easy way to remember that. And then if we have a symmetric, they're all basically going to be the same. So they'll all just be right there in the middle, which makes sense. I mean, the median is a center data point, so you get halfway through the data, you're right there. Mode is the tallest, and then the mean, if it's symmetric, any of the low values will offset the higher values when you're adding them up. So, so that makes sense. And then just make sure you kind of understand this. I don't know that there's a easy way to memorize it other than to kind of understand why it is the way it is. But you could have questions on the homework or whatever that say we have data set that's skewed left or skewed right, which would be higher, the mean or the median. So you kind of might need to know how to answer those questions. And then kind of the last thing we want to talk about here is standard deviation. And I don't really have too much to write, but we could write a definition for standard deviation. So standard deviation is the average distance from the data points to the mean. So it's a measure of how spread out the data are. So if the data values are close to the mean, they're less spread out, then the standard deviation is small. If they're far from the mean, which means they're more spread out, then the standard deviation will be large. Now these two things definitely either understand or memorize because they are pretty important. For symmetric distributions, you're going to use the mean and the standard deviation to summarize the data. For skewed, we're going to use the median and the IQR. And the reason for that is when we're symmetric, the outliers are not quite as important because if it's symmetric and you have lower outliers, you also have upper outliers. And so they kind of cancel each other out. But with skewed, you're only going to have outliers in one direction. And so that will change the mean. It will also make the data seem like it's more spread out than what it is. So like this data has a wide range, but as far as, I mean, most of the data is going to be between here and here. And so the typical data points are not that spread out. But if you look at, you take them all into account, then they do seem a little bit more spread out. So with skew distribution, it's better to use the mean or the median and IQR. All right, and then last we'll just look at a quick little example regarding standard deviation. So order the order the histograms below from smallest standard deviation to largest. And so this would go, so the C would be less spread out because you have that one mode in the middle. It's pretty symmetric. And then A is actually going to be the next in the increasing order, and then we'll have B next. So all of those data points on the end make B be more spread out than A. So, okay, so that's it. I'm going to find a YouTube video and we'll learn some things on the calculator. You need to be able to use the calculator to calculate, calculate median, mean, standard deviation, the quartiles, on and on. So we can, I'll post a video, won't be me, it'll be a YouTube video of how to do that. So make sure you watch that because the calculator stuff is not hard, but you need to practice it enough to where it is almost second nature and you don't really have to think about how to do it because it's very simple once you know how to do it. But if you don't know how to do it and you got to figure it out, then that can cause some issues. So look for that and we'll get you in the next chapter.